Welcome students to this particular session related to control charts. So far we have understood the meaning of control chart, which are the different types of the control charts and how to plot the control charts. Basically there are two types of control charts. The first one, that is the control charts for the variables, and second one, that is the control charts for attributes. Under the control charts of variable, we have covered X bar chart and R chart till the last session. Now in this particular session, we are going to understand which are the different types of the control charts for attributes. Basically, we are going to cover two different types of the control charts for attributes. One is P chart and second one is C chart. And we also will understand how to plot or how to prepare the P chart as well as C chart. So control charts for attributes. Attributes is not a quantitative thing. Attributes generate the data that are counted. It means that such as number of defects. Okay, number of defects can be counted. Suppose number of cracks available on the surface of a workpiece. So we can identify, we can calculate, or we can count the number of cracks available on the surface of a workpiece, and on the basis of the limit, we can either reject that workpiece if the number of defects or number of cracks are more than the prescribed limit, then we will be rejecting that workpiece. And if it is inside or within the limit that we set, that is then that workpiece will be accepted. Okay, so basically on the we are basically going to count a particular kind of defect or a particular kind of geometry or particular kind of attribute. Okay, and then after we are going to either select the whole lot, or we will go for the rejection of the whole lot. So first of all, let us understand what is P chart. The P chart is nothing but a control chart that is used to monitor the proportion of defective or defects in a process. Proportion of defects, it means we are going to identify the number of defects in each sample. There will be several items, or sample size will be there. In each sample, small n number of items will be there, and on all those 9 items, we will be calculating the number of defects, and it will be converted into percentage. That's why it is called as proportion of defectiveness or proportion of defects in a process. While a C chart is a control chart that is used to monitor the number of defect per unit. Okay, so let us understand how to prepare the P chart in this particular video, and we will see how to prepare the C chart in next upcoming video. So to prepare any control chart, we know that we have to decide the upper limit and lower limit, and then after we are going to plot the different data points on those graph on that particular chart, and we will be identifying whether any data point is crossing the UCL or the LCL. If any data point is crossing the UCL or LCL, then the process will not be under control. We can conclude that the process requires some corrective steps and it is not under control. Okay, so the same way, same methodology is applied over here. To prepare the P chart, we will require to identify the UCL first and LCL. Then we are going to plot this UCL and LCL on the chart, and then we will be plotting different data points on that chart. And on the basis of that chart, we will be deciding the whether the process is under control or not. So let us understand the first terminology, that is nothing but the P bar. P bar is nothing but the total number of defects or defectives divided by total number of observations. Then sigma P is nothing but equal to under root P bar into 1 minus P bar divided by small n. Over here, small n is nothing but the number of quantity in a sample, or we can call it as a sample size. Then to find out the UCL for the P chart, it will be equal to P bar plus Z into sigma P. Z is nothing but the number deviation. Then LCL P can be found out by using the P bar minus Z into sigma P. The value of Z will be available to you in the data. Because of this particular formulas are for an approximation, so sometimes you may be getting the LCL value in below 0 in negative. Okay, so at that time the proportion cannot be 0. Okay, but still you will be getting the value of LCL below the 0. So at that time what may happen, what you can consider, you can consider the LCL as 0. Okay, so in that kind of case, when the LCL is negative, you are finding or you are calculating by using this equation. In that case, the proportion or the LCL cannot be negative. So you should consider the LCL as 0. Now let us go for an example to prepare the P chart. So over here, the example has been given to you, in which you are told that an inspector counted the number of defective monthly billing statements for telephone company in each of 20 samples. Consider Z is equal to 3 and each sample contained 100 statements. Means that total there are 20 samples are taken as shown in the table. Sample number is starting from 1 to 20 and each sample is made of 100 statements. 100 bills are there in each sample. Okay, so total number of statements are 100 into 20. So small k is nothing but 20. That is the sample number of samples, and small n, that is the sample size, is equal to 100. So over here, if we see the sample number 1 consists of number of defective bills are 7. Then in sample number 2, number of defectives are 10. Likewise, if you will refer the sample number 14 randomly, so over there in sample number 14, number of defective has been identified as 10. So total, if you will see, starting from sample number 1 to sample number 20, total number of defectives is 220. Okay, and total number of bills or statements that has been considered over here, that is 20 into 100, so 2000. Now, by using the following equation, by using the equations given below, we will be deciding the value of UCL and LCL. Now let us see over here. P bar is equal to total number of defectives divided by total number of observations. So as we discussed earlier, the total number of defectives are found as 220. So this 220 is nothing but the summation of number of defectives for each sample. Okay, and divided by total number of observations. Total number of observations means that k into n. Small k, that is nothing but the number of samples, and each sample carries 100 items, so that is small n. So total number of observations are 20 into 100, while the number of defective is 220. So if you will take, or if you will simplify this calculation, then it will be equal to 0.11. Now need to find out the sigma p, that is equal to under root p bar into 1 minus p bar divided by n. So if you will put all the values over here, you will be finding 0.0313 as the sigma p. Now, after finding the p bar and sigma p, if we put these values in the equation of UCL and LCL, then the UCL for the P chart will be equal to 0.2039 and LCL is equal to 0.0161. So over here you are able to see it is very less number 0.0161. Okay, so it is more than 0, but it is very nearer to 0. Now this particular values 0.20 and 0.01 or 0.2039 as a UCL and 0.0161 as a LCL. We are going to plot this on the chart. Now you just see in this particular chart, we have taken the sample numbers on x-axis and on y-axis the fraction defective has been taken, and we are able to see the LCL has been plotted over here, that is equal to 0.0161, and UCL that is nothing but 0.2039, while the P bar value which we achieved as a 0.11, so that P bar is nothing but the mean line, so it has been plotted over here as a 0.11. Now what to do? We are going to plot the number of defectives for each sample over here. Now if you will see the sample 1, the number of defective is 7. Okay, so if you will see the 7 is not available on the y-axis. Okay, over here, why it is not available? Because this 7 is number of defectives and P chart is the proportion chart. Okay, so that's why if if it is a proportion chart, then you should make this 7 into percentage form. Okay, so total sample size is 100. Out of that 100, out of those 100, 7 are defectives. It means that 7%, or we can say that 0.07. 0.07 will be the proportion or the fraction defective for the sample 1. Same way for sample number 2, 10 number of defectives are there. So 10 divided by small n. Over here small n is 100. So 10 divided by small n, that is equal to 10 divided by 100. It will be equal to 0.1. So over here you are able to see at sample number 2, a point has been marked over here at 0.10 reading of the fraction defective on the y-axis. Okay, likewise all the data points will be plotted over here, and after plotting all the data points, we can see that the plotting the control limits and the sample fraction defective, we can see that the last value is above the upper control limit. What is the highest limit? That is 0.2039. But if you will see the sample number 20 over here, the number of defective is 21 in this particular table. So it means that if you will divide this 21 with 100 or small n, so it will be 0.21. Okay, and upper limit is 0.2039, while the limit that while the value that we are achieving over here for sample 20, that is more than UCL. It means that it is crossing the UCL line. Okay, so for sample 20, we are achieving the data point above the UCL. So that's why from this P chart, we can say that the process is not under control and some corrective actions are required. So in this way, the P chart can be prepared. Thank you.